Hello everyone, welcome to today's lecture. In today's lecture, we will practice some more questions based on trigonometric functions and equations. In the last section, we had covered till question number 12. So in this section, we will start from question number 13 and we will discuss till question number 18. The images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. Let's start with question number 13, which says, in a triangle PQR, angle R is equal to pi by 2. If tan p by 2 and tan q by 2 are roots of this quadratic equation, ax square plus bx plus c equal to 0, where a not equal to 0, then which option will be correct? Right. So the hint of this question is, the condition of roots of the quadratic equation, that is, if two roots are alpha and beta, then alpha plus beta will be equal to minus b by a, and alpha into beta will be equal to c by a, right? Therefore, tan p by 2 plus tan q by 2 will be equal to minus b by a, and tan p by 2 into tan q by 2 will be equal to c by a, right? And in this way, you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part T. Since tan p by 2 plus tan p by 2 and tan q by 2 are the roots of this quadratic equation, therefore, tan p by 2 plus tan q by 2 will be equal to minus b by a, and tan p by 2 into tan q by 2 is equal to c by a. Also C, if PQR are angle of a triangle, then P plus Q plus R is equal to pi. Therefore, P by 2 plus Q by 2 plus R by 2 is equal to pi by 2, right? And we know that angle R is equal to pi by 2. Therefore, R by 2 will be equal to pi by 4, right? Therefore, P plus Q upon 2 is equal to pi by 4. That is pi by 2 minus pi by 4, which is pi by 4. Now, P plus Q by 2 is equal to pi by 4. Apply tan both sides. Therefore, tan P by 2 plus Q by 2 is equal to tan pi by 4. Now, tan P by 2 plus Q by 2 can be written as tan P by 2 plus tan Q by 2 upon 1 minus tan P by 2 into tan Q by 2 is equal to 1. Now, tan P by 2 plus tan Q by 2 is equal to minus V by A, and tan P by 2 into tan Q by 2 is equal to C by A. Right? Therefore, we can write minus P by A upon 1 minus P by A is equal to 1. Right? Therefore, after doing simplification, the equation converts to C is equal to A plus B, right? C is equal to A plus B. Therefore, option C is the right choice. Clear? Option C, where C is equal to A plus B, is the right choice. Got it? Let's move to the next question, question number 14, which says, if cos alpha plus beta is equal to 4 by 5 and sin alpha minus beta is equal to 5 by 13, where alpha beta is between 0 to pi by 4, then tan 2 alpha is equal to, we basically have to find the value of tan 2 alpha. See, alpha plus beta is 4 by, cos alpha plus beta is 4 by 5. Therefore, we can find alpha plus beta, that is cos inverse 4 by 5. And we can find alpha minus beta sin inverse 5 by 13. Therefore, we got alpha plus beta and alpha minus beta. Now we can add this alpha plus beta and alpha minus beta to get the value of 2 alpha. Right? 2 alpha, and also we will add right hand side. And after that, we can apply tan both sides. Right? And after further simplification, we will easily get the answer. Okay? So you have 10 seconds to solve or think about this question. After 10 seconds, we will discuss the solution. Okay? Okay, let's move to the solution part. Since cos alpha plus beta is equal to 4 by 5, this implies alpha plus beta is in first quadrant, right? Also, sin alpha minus beta is equal to 5 by 13. This also implies alpha minus beta is in first quadrant, right? Now, 2 alpha is equal to alpha plus beta plus alpha minus beta. Therefore, tan 2 alpha can be written as tan of alpha plus beta plus alpha minus beta. Therefore, it can be written as further tan alpha plus beta plus tan alpha minus beta upon 1 minus tan alpha plus beta into tan alpha minus beta, right? Now, we know that since cos alpha plus beta is 4 by 5, therefore, tan alpha plus beta will be 3 by 4, 3 by 4 by using properties of triangle. And also, sin alpha minus beta is given 5 by 13. Therefore, tan alpha minus beta will be equal to 5 by 12 by using properties of triangle, right? Now, you can put the value of tan alpha plus beta and tan alpha minus beta. Therefore, we will get 3 by 4 plus 5 by 12 upon 1 minus 3 by 4 into 5 by 12, which after simplification, you will get tan 2 alpha will be equal to 56 upon 33. 56 upon 33. Clear? Therefore, option B, 56 upon 33 is the right answer. Got it? Now, let's move to the next question. Question number 15, which says, if sin alpha is equal to x and sin beta is equal to y, and sin alpha plus beta is equal to z, then cos alpha plus beta as a rational function is. Cos alpha plus beta as a rational function is. So see, the hint of this question is we are given sin alpha, which is x, cos sin beta, which is y, and sin alpha plus beta is equal to z. Now we can try to break sin alpha plus beta as a function of z, right? And replace sin alpha with x and sin beta with y. And after further replacement and simplification, you will be easily get the value of cos alpha plus beta, right? So in this way, you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds, we will discuss the solution. Okay. Okay, let's move to the solution part. We have x is equal to sin alpha, y is equal to sin beta, and z is equal to sin alpha plus beta. Right. Therefore, z can be written as sin alpha cos. Since sin alpha plus beta is sin alpha cos beta plus cos alpha sin beta, right? Now, sin alpha is x and sin beta is y. Now, replace sin alpha with x and sin beta with y, right? Therefore, z is equal to x cos beta plus y cos alpha, right? Now, let's square both sides. Therefore, z square will be equal to x square cos square beta plus y square cos square alpha plus 2xy cos alpha cos beta. Therefore, z square will be equal to x square. Since c, sin beta is y. Therefore, sin square beta is y square. Right. So cos square beta can be written as 1 minus sin square beta. Therefore, it is cos square beta is basically 1 minus y square, and y square is basically sin square beta. Plus y square into cos square alpha can be written as sin alpha is x. Therefore, sin square alpha will be x square. Therefore, 1 minus cos square alpha, cos square alpha can be written as 1 minus sin square alpha, which is 1 minus x square, right? Therefore, y square into 1 minus x square plus 2xy into cos alpha into cos beta. Now, z square is equal to x square into cos square beta plus y square into cos square alpha plus 2xy cos alpha cos beta. Therefore, z square is equal to x square into 1 minus y square plus y square into 1 minus x square plus 2xy into cos alpha cos beta. Therefore, z square is basically equal to x square plus y square minus 2x square y square plus 2xy cos alpha cos beta. So, z square is equal to x square plus y square plus 2xy cos alpha cos beta minus sin alpha sin beta, right? Cos alpha cos beta minus sin alpha sin beta. We have replaced one x with sin alpha and one y with sin beta. Clear? You can easily conclude. Therefore, z square will be z square minus x square minus y square will be equal to 2xy cos of alpha plus beta. Cos of alpha plus beta, right? Now, since we have to basically find cos alpha plus beta, right? Therefore, cos alpha plus beta will be equal to x, z square plus z square minus x square minus y square upon 2xy. 2xy will go in the denominator, right? Clear? Therefore, cos alpha plus beta is equal to z square minus x square minus y square upon 2xy. Therefore, option B is the right choice. Z square minus x square minus y square upon 2xy. Got it? Now, let's move to the next question, question number 16, which says, let alpha and beta be such that alpha minus beta is between pi to 3 pi. And if sin alpha plus sin beta is equal to minus 21 upon 65, and cos alpha plus cos beta is minus 27 upon 65, then the value of cos of alpha minus beta upon 2 is. So, see, the hint of this question is, we are given sin alpha plus sin beta, which is minus 21 by 65, and cos alpha plus cos beta, which is minus 27 upon 65. Now, you can try to convert this the angle formula, that is sin alpha minus beta, into a half angle formula, cos alpha minus beta by 2, right? Here, and since you will get two values of cos alpha minus beta by 2, and after that you will try to conclude, since alpha minus beta is is between pi to 3 pi, therefore alpha minus beta by 2 will be between pi by 2 to 3 pi by 2, right? So according to this, you will decide the sign of cos alpha minus beta by 2, right? So in this way, you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds, we will discuss the solution, okay? Okay, now let's move to the solution part C. Since we are given that sin alpha plus sin beta is equal to minus 21 upon 65, let's suppose it as equation 1. And cos alpha plus cos beta is equal to minus 27 upon 65. So let's assume this as equation 2. Now, let's square both equation 1 and equation 2. On squaring and adding equation 1 and equation 2, we will get sin square alpha plus sin square beta plus 2 sin alpha plus 2 sin alpha sin beta plus cos square alpha plus cos square beta plus 2 cos alpha cos beta is equal to minus 21 upon 65 square plus minus 27 upon 65 square, right? Therefore, see, sin square, if we add this, sin square alpha plus cos square alpha will be 1, sin square plus beta plus cos square beta will be 1 plus 1 will be 2. Therefore, 2 plus 2, you can take 2 common, then sin alpha sin beta plus cos alpha cos beta is equal to 441 upon 4225 plus 729 upon 4225. Clear? Now, let's take 2 common. Therefore, 2 into 1 plus cos alpha minus beta. After addition, in the right hand side, you will get 11760 upon 4225. Therefore, now, this 2 will go on bottom side. See, 1 plus cos alpha minus beta can be written as 2 cos square alpha minus beta, right? 2 cos square alpha minus beta. Therefore, 2 into 2 will be 4. Therefore, this 4 will go in the denominator of the right hand side, right? Therefore, cos square alpha minus beta by 2 is equal to 1170 upon 4 into 4225. Therefore, cos square alpha minus beta, after simplification, cos square alpha minus beta by 2 will be equal to 9 upon 130. Now, cos alpha minus beta upon 2 can be plus minus 3 upon root of 130. Now, since alpha minus beta is between pi to 3 pi, therefore alpha minus beta by 2 will be between pi by 2 to 3 pi by 2, that is in the second quadrant. And cos theta is negative in the second quadrant, therefore cos alpha minus beta by 2 will be equal to minus 3 upon root 130. Minus 3 upon root 130. Right, therefore minus 3 upon root 130 is the right choice. Got it? Minus 3 upon root 130. Okay. So let's move to the next question, question number 17, which says it is a question of conditional solution, in which it is given that if a plus b plus c is equal to pi and cos a is equal to cos b into cos c, then tan b into tan c is equal to what? So the hint of this question is, since we have to basically find tan b into tan c, right? Therefore, there is no a terms. Clear? We have to calculate. Therefore, we will replace a with pi minus b plus c. Pi minus b plus c. Therefore, cos of pi minus b plus c is equal to cos b minus cos b into cos c. Now, cos of pi minus b plus c will be equal to minus of cos b plus c, right? Now, after further simplification, you will easily get the value of tan b into tan c, right? So in this way, you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds, we will discuss the solution, okay? Okay, let's move to the solution part C. Since a plus b plus c is equal to pi, therefore a is equal to pi minus b plus c. Now we have cos a is equal to cos b into cos c. Therefore, a can be replaced with pi minus b plus c, right? Therefore, cos of pi minus b plus c is equal to cos b into cos c. Therefore, minus of cos b plus c is equal to cos b into cos b. Now, cos b plus c can be further solved as minus of cos b cos c minus sin b sin c is equal to cos b cos c. Therefore, after further simplification, we will get sin b sin c is equal to 2 times cos b cos c. Now, let's move cos b cos c on the left hand side. Therefore, we will get tan b into tan c is equal to 2. Right? Tan b into tan c is equal to 2. Therefore, option B, 2 is the right choice. Got it? Option B is the right choice. Okay. Okay, let's move to the next question. Question number 18, which says, if 10x is equal to 1 plus 2 to the power minus x whole to the power minus 1 and tan beta is equal to 1 plus 2 to the power x plus 1 whole to the power minus 1, then alpha plus beta is equal to. So, see, we are given tan alpha and tan beta. Therefore, we can easily find tan alpha plus beta. Tan alpha plus beta will be tan alpha plus tan beta upon 1 minus tan alpha plus 1 minus tan alpha into tan beta. Right? So, in this way, you can try to approach this question. And after further simplification, you will easily reach to the answer, right? So, in this way, you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds, we will discuss the solution, okay? Okay, let's move to the solution part C. Tan alpha plus beta is equal to tan alpha plus tan beta upon 1 minus tan alpha tan beta. Therefore, tan alpha is basically 1 upon 1 plus 2 to the power minus x, and tan beta is equal to 1 upon 1 plus 2 to the power x plus 1, right? Therefore, it can be 1 upon 1 plus 2 to the power minus x can be written as 1 upon 2 to the power x. Right? Therefore, tan of alpha plus beta is basically 1 upon tan of alpha plus beta will be tan alpha plus tan beta upon 1 minus tan alpha into tan beta. Therefore, it can be written as 1 upon 1 plus 2 to 1 upon 1 plus 1 by 2 to the power x plus 1 upon 1 plus 2 to the power x plus 1 upon 1 minus 1 upon 1 plus 2 to the power 1 upon 1 plus 1 by 2 to the power x into 1 upon 1 plus 2 to the power x plus 1, right? Therefore, tan of alpha plus beta is equal to 2 to the power x plus 2 into 2 to the power 2x plus 2 to the power x plus 1 upon 1 plus 2 to the power x plus 2 into 2 to the power x plus 2 into 2 to the power x minus 2 to the power x. Now, this 2 to the power x and this 2 to the power x will be cancelled out. Now, you can easily see that numerator and the denominator are the same, right? All the terms of numerator and the denominator are the same. Therefore, it will cancel out, and right hand side we are left with 1. Therefore, tan of alpha plus beta is equal to 1. Right? Therefore, alpha plus beta is equal to pi by 4. Got it? Alpha plus beta is equal to pi by 4. So, option B is the right choice. Option B, pi by 4 is the right choice. Got it? Pi by 4 is the right choice. So, in this way, we have discussed a lot of different types of questions based on trigonometric functions. Hope you understood each and every concept and how to apply concepts in the question parts. And hope you liked the lecture. Okay. Thank you so much.